Hello. So, how do we follow dependency inversion principle? How do we comply with dependency inversion principle? First, think about your application. Think about your code in terms of layers. Find policy layers, mechanism layers, utility layers. Then, determine abstractions. Find good abstractions in your application. Abstractions is something that remains true regardless of how you implement it. For example, if you had some class that needs to store some data, and you would need some kind of storage. So storage would be your abstraction. You'd have some kind of storage interface, and there would be many different ways to implement it. You could have some local storage with just a file, appending something to this file, like some login system, or you might have a database, some kind of database, or store remotely. You may use some kind of remote storage, use FTP, or you may use Amazon Web Services, something like that. Doesn't matter, many different ways to implement it, but the basic idea remains the same. It's still storage, with operations like adding to the storage, removing to the storage, updating, and so on. So storage would be your abstractions, and you need to find such abstractions in your application. Then create those abstractions and add them to your code, and depend on abstractions instead of implementation details, instead of concrete classes, and in places which are volatile, if such classes that you depend on are volatile. So if you replace concrete classes by abstractions, if such classes are going to change often. So we shouldn't add abstractions everywhere in our code. Instead, we only add abstractions where this code changes frequently. For example, when we have some kind of standard library class like std_string, we don't replace it by abstractions. It doesn't change often, right? And then you may kind of define some heuristics, some kind of rough rules to follow. So first, we use references to abstract-based classes. Then we do not inherit from concrete classes, and we do not override implement methods. So this is some kind of heuristic that we need to follow, but it's not an obligation. We just try to follow these rules, but it's not mandatory. So. And then to create abstractions, for abstractions we may use dynamic polymorphism with virtual functions and inheritance and with abstract base classes, or we may use static polymorphism with templates, or both. In C++ we may use these features of the language to implement abstractions, and we may also have some kind of type erasure, and we may have some kind of complex type erasure that is implemented using both dynamic and static polymorphism. There are many different ways to do it, but these are two basics, features of the language that allow us to have abstractions. And then we distribute such interfaces. We distribute abstractions usually with clients who own those interfaces and who depend on the interfaces. And we don't put these interfaces with classes that implement those interfaces. So some interface file, some abstract-based class will be in the same package, in the same library as we have the client, because it's the client who needs it and who defines what it needs, right? And if there are many clients who depend on such interface, or such multiple interfaces, then those interfaces go they are kept in their own separate package or library, and then many other clients will depend on these interfaces, and this allows much better reusability of such interfaces. And similarly, we may put C++ concepts that are available since C++20. We may put these concepts also in client packages or in their own interfaces, concepts packages. This will be much more readable. And also we use what is called dependency injection. And dependency injection basically tells us that basically means that we separate the creation of client's dependencies from client's behavior. So client doesn't create its dependencies. And we use also factories. And you may find more information on factories on the internet or other courses. This code isn't about patterns, but factories is a simple idea. Basically, you have some kind of other function, some kind of other class that is responsible only for creating instances of some other class or instances of classes that implement some kind of interface. And dependency injection, basically, according to dependency injection, we have a client, service, and injector. And client depends on services, but client does not create services. There is some other non-client code that passes services to the client, and we call this code injector. And the client only has to care about the interfaces. The client only knows interfaces. It doesn't need to know implementation details, how to create services. The client only knows about the interface, and then some other code, injector, will create those. Will create interfaces. Will create instances of concrete classes that implement the interface, and this injector code will pass services to the client. So it's basically the same as parameter passing, but just with clear intent to decouple and with the use of abstraction. And there are also dependency injection frameworks, but you would rather use them in some large and complex projects. This dependency injection frameworks isn't something that you use on an everyday basis, in every project. You shouldn't use it in every project. This is something that you should really need this before you use dependency injection frameworks. And finally, I would like to draw your attention to a few points about dependency inversion principle. Which is, first of all, there is no free lunch, and abstraction increases code complexity, and you shouldn't add abstractions everywhere. There are too many abstractions may be hard for developers. They will find to jump to many different places, to many different interfaces, and so on. And excessive abstractions can even do more harm than good. So we replace concrete implementations, concrete classes, we replace details by abstractions only where such classes are changing often. And usually this is our own classes, our own code, and standard library classes or some third-party libraries, they don't contain classes that will change often in our application, or they will not change at all. So that's basically applies only to our own application classes in our applications that we build. And we don't apply dependency inversion principle to classes that do not change or are not likely to change often. So keep that in mind. And you should also understand that when we have abstractions and we apply dependency inversion principle, this allows us to use mocks in unit tests of our classes, because we replace concrete implementation with their mocks. Mocks will inherit from the interface, will implement the interface, will mock implementation. And usually mocks like Gmock, Google mocks, they're implemented with inheritance. And it sometimes happens in projects that basically the only other implementations of your interfaces are mocks. You have one implementation used in production, and other implementation is mock for unit tests. And that's not something really good, although it's not really bad, but not good, not terrible, but still it happens in the projects. And you may find some people use interface, create abstract base class, and use abstraction only just to have this ability to add mocks and unit test classes. So usually try not to add abstractions only because it will allow you to use mocks, and then test class is easier. And finally, I would say that the hardest part, and in general, this dependency inversion principle, the idea is simple. You use abstractions, but the hard part of this principle is that in real life projects, good abstractions, good interfaces are really hard to define. When you have large project and you have interfaces, it's hard to know what would be the best interface, what would be the best abstraction. So that's something that comes, with the practice and knowledge of your product and with domain knowledge. So that's all for this video. See you next time.